Hello, dear students. Myself, Dr. Rakesh Parmar, and today we will learn about the maxima and minima of functions of two variables. Here, what is the procedure or what is the concept by which we can find the maxima and minima of two variables. So, on the screen, you are seeing that u equal to fxy is a function. To find the maxima and minima, first we will take the partial derivatives up to second order, and del f by del x, del f by del y, these are the partial derivatives of first order, and then del square f by del x square, del square f by del xy, del square f by del y square. To find the maxima and minima, we equate first order derivative with 0 and find the value of x and y after getting some equations and on solving those equations. And the values of x and y which we are obtaining by solving the equations, we will put them into the second order derivative to find the value of r, s and t. R is nothing but the value obtained from del square f by del x y del x square, and s is the value obtained from del square f by del x del y, and t is the value obtained from del square f by del y square. And after finding this, we will find rt minus s square. So rt minus s square is greater than 0, that is positive, and r is also positive, greater than 0, then the function has a minimum value at the point obtaining in the first conditions. So this is the condition of finding minima. And if rt minus s square is greater than 0 but r is less than 0, then it is the condition of maxima, and similarly on putting those values we will find the maximum value of the u. And if rt minus s square is less than 0, then function neither has maxima nor minima. There are other methods to find the maxima or minima. And if rt minus s square equal to 0, then the condition is unclear. It means that this is not the clear conditions by which we can find the maxima and minima. So after knowing this concept, now we will solve some problems. Here the problem is u equal to xy plus aq by x square plus aq by y. Now on partial differentiating the given equation, we can find del u by del x is equal to y minus a cube by x square, del u by del y equal to x minus a cube by y square. Now the second order derivatives, del square u by del x square, del square u by del xy, and del square u by del y square, these are the second order derivatives. To find the maxima and minima, we equate first order derivative with 0. So del u by del x equal to 0 and del u by del y equal to 0. By equating those, we get relations a cube equal to x square y, a cube equal to xy square. So on solving this a cube equal to xy square and x square y, we get x square y minus xy square, and xy taking as a common, then x minus y in a bracket equal to 0. So x minus y equal to 0, that is x equal to y. Putting x is equal to y, we get value x is equal to a and y is equal to a. This is the point where we can find either the maxima or minima. Presently we can't say about what is the value, whether it is maxima or minima. For getting maxima and minima, there is a need of further investigation to find the value r, s and t. So now we put x is equal to a and x is equal to y is equal to a for the second order derivatives and get the value of r, s and t. So you can see that here r is equal to 2, s is equal to 1 and t is equal to 2. After putting this value, we will find our difference rt minus s square. So rt minus s square is nothing, that is 2 into 2 minus 1 square, that is 4 minus 1 means 3, and 3 is a positive value, that is rt minus s square is greater than 0, and r is 2, that means r is greater than 0. So this is the condition of minima, and we will get the minimum value at x is equal to a, y is equals to a. So the minimum value is u minimum a plus a cube by a plus a cube by a, that is u minimum equal to 3a square, and this is the minimum value. And here some problems for the assignment, you will solve this problem and post me. Okay, thank you.